In this presentation, we're going to look at sequences and series, and in particular, we're going to look at a geometric series question. So the question here is as follows. This is a short question. Find the geometric series that has the second term equal to 3 and a sum to infinity equal to 12. Now, essentially what we're asked to do here is using the usual notation, identify the values for A and R. So, two things we are told: that the second sum is equal to, the second value is equal to 3. So let's just make a quick note of that. That the series works out like this. We can write it sort of like as follows: A plus AR plus AR squared, and so on. That is equal to 12. And we are also told that this term here is equal to 3. So that's so far so good. The second thing, there's actually, let's just pick up on that. The sum to infinity is equal to 12. Now, it's very curious that we are told that it can somehow we can get a specific value. The reason, well, essentially what I'm going to say is, for the time being, we're going to guess that the common ratio is less than or equal to 1. Okay? Although if it was greater than 1, then we wouldn't be able to express the sum to infinity as a whole number. So we're just going to sort of, for the time being, guess that R is less than or equal to 1, and we'll move on from there. Now, actually, as it happens, it's a very good guess, but we'll just sort of prove it first. So let's just piece all our information together. AR, A times R even, is equal to 3. Okay, that's A times R. Actually, I shouldn't have written it so close together. Now, the sum to infinity is 12. Okay. Now, if the common ratio is less than or equal to 12, or sorry, is less than or equal to 1, then the sum to infinity is equal to A over 1 minus R. Okay, so what we have here is two equations and two unknowns, and that makes our argument that R is less than or equal to 1 much stronger again. Now let's write them out again. This time I'll write it in black. A times R, which is equal to 3, and 12 is equal to A over 1 minus R. Okay, I'm going to write out the second expression there again. 12 times 12 times, actually I've just gone a bit too fast there, 1 minus R is equal to A. So that's that second expression there again. So those are the two expressions we have. A times R is equal to 3. 12 times 1 minus R is equal to A. Let's simplify that now. That's 12 minus 12R is equal to A. So what we can do is substitute in one of the values into the other expression. So what I'm going to say is that R here, back up the first one here, R is 3 divided by A. Okay, so I'll probably start this in the new page here. R is 3 divided by A, and 12 minus 12R is equal to A. Do you know what? Actually, sorry, I'm going to write this A. A equals 3 divided by R. That might just help things speed up a bit. So it's just a re-expression of that. These two expressions are just the re-expressions of each other, doesn't really. So let's put in A there. 12 minus 12 times R equals 3 divided by R. Okay, let's multiply both sides by r. So we have 12r minus 12r squared equal to 3. Oops, forgot the r there. 12r minus 12r squared. Let's rewrite that as minus 12r squared plus 12 r, minus 3 equal to 0. I'm just taking it in baby steps here. And let's divide both sides by minus, or divide the whole thing by minus 3. So we have 4r squared minus 4r minus 1 equal to 0. Now what we're going to do here is use the minus b expression, the minus b equation. So we're going to use that equation there. 4r squared minus 4r plus 1. Sorry, do you know what? That should be a plus 1 there. I'm dividing by minus 3. So minus 4r plus 1. So minus b is, that means it's plus 4. Plus or minus the square root of b squared, which is 16, minus 4ac, which is 16, all over 2a. And that's 2 divided by 4, so that is 8. 2 times 4 is 8. So that works out to be 4 plus or minus 0 all over 8, and that works out to be 1/2. So we have one answer for r only, and r is equal to 1/2. What does that make a? So remember, a times r is equal to 3. That means a times 1/2 of something is equal to 3. And that means a is equal to 6. Okay, so that's it all done. So a plus ar plus ar squared, and so on. That's equal to 6 plus 3 plus 3 over 2, and so on. That we'll actually write that as follows. That is equal to a times r to the power of k is 6 times 1/2 to the power of k, and that's our answer. K is equal to 0 to infinity. That's a very formal way of writing it. Anyway, that's essentially the key part of it. There was identify a and r, and we've done that. So that ends the presentation.